Alright, geometry. Unfortunately, we're in that part of the year here where I will be missing at least once, probably twice a week for 8th period. So you're going to be getting used to these videos. Okay? 9.4 today, rotations. And if this goes too fast, number one, these are all screenshots out of your book for the most part. And number two, this is on YouTube. So you can go back and find it. Handke Geometry 9.4. A rotation is a transformation in which a figure is turned around or about a fixed point called the center of rotation. So here's our focus point that we're kind of going from. Usually we pick 0, 0. Okay, and it was up here, and I twisted it this way. Rays drawn from the center of rotation to a point in its image form the angle of rotation. So this is actually, like this little stem is part of the original graph here. I don't know why they made it so confusing. They should have just used the triangle. Okay, put this ray up to this point, and they rotated it 40 degrees, and that brought everything over with it. A rotation about point P through an angle X will take every point Q in the plane to point Q prime, so that one of the following properties is true. Q is not the center of rotation P, then QP to Q prime P, a measure of angle QP, Q prime would equal X degrees, so QP, Q prime would equal 40 degrees. Or if Q is the center of rotation, then the image of Q is Q. So if Q was the center of rotation, this thing, the bottom point here, then that wouldn't move and everything else would. Rotations can be clockwise or counterclockwise. In this chapter, all rotations are counterclockwise. It means they're going backwards to the left. Okay? Alright, we won't necessarily be doing too many of these, so we're not going to worry about that. Rotations about the origin. This is the stuff we're going to be doing. You can rotate a figure more than 180 degrees. This diagram shows rotations of point A, 130 degrees, 220, and 310. A rotation of 360 would return it to its original coordinates. There are coordinate rules that can be used to find the coordinates of a point after rotations of 90, 180, and 270. And that is the stuff we're going to be doing. We're going to be doing the classics here, 90, 180, 270. Here are your coordinate rules. This is a big one. You might want to have that written down on the top of your homework paper. Okay, this is also screenshot right out of your book. So if you don't get it written down now, I would copy that out of your book and put that on the top of your homework paper or worksheet that you're going to get today. That way you're not flipping back and forth in your book all the time. Okay, so if we're going to go rotation of 90 degrees, right angle, A comma B turns into negative B comma A. Flip A and B, change the sign on the front. For a rotation of 180, AB turns into negative A, negative B. So the numbers or the coordinates stay where they are, they just switch signs. For a rotation of 270, A and B switch, and you change the sign on what was your X, but is now your Y. So let's say we had a 3, 2. 3, 2, and I did this rotation here of 90 degrees. Okay, I'm going to flip-flop these to 2, 3, and now I change the sign on my front one. This one was positive, now it's going to be negative. Negative B comma A. Rotation of 180, they stay in the same order, but they both switch signs. And for rotation of 270, they flip-flop. 2, 3, but now the back one changes. All right, so there's a little example for you on how all those would work. This is a type of problem here that you can be doing a lot of today. And I like to write them down on the side first. A is -2, 4. B, we have -4, -1. C is -3, -3. And D is -1, 0. Okay, our 90-degree rule is -B, comma A. A prime, B prime, C prime, D prime. Okay, so this one goes to the back. So -2 in the back. 4 comes to the front and changes signs. -4, -2. -1 comes to the front and changes signs, so +1. -4 goes to the back. -3 goes to the back. This -3 comes up to the front and changes signs. 0 can't change sign, it's still 0. -1 goes to the back. Okay, so let's see our first one here, -2. Oh my. I'm gonna go blind trying to read this grid. 1, 2. 1, 2, 3, 4. Whoa. 2, 3, 4, 1. 3. What kind of grid is this? This is not looking very clean, is it? And D is at -1, 0. A was at -2, +4. That's going to make a big difference. 1, 2, 3, 4. And D is at -1, 0. Much better. All right. A prime, -4. -2. B prime is 1, -4. C prime is +3, -3. D prime is 0, -1. A, B, C, D. Okay. Well, I might have been off by a few dots around there somewhere, but you can kind of see the rotation swinging around over that way. And it's tough getting down there on that grid. Look how small. It might look big to you, but let's zoom out here and let's see actual paper size of what I'm trying to look at. Yeah, that's tough. Getting too old. All right. We are not going to be doing the matrices yet. Okay, so if you get anything in a matrix form, you're going to turn it into a regular x comma y. You're going to turn it into an x comma y. And then use your coordinate rules. Rotations are isometries, isometries. They maintain all congruences. That's good. Just like everything else we've been doing. So if they maintain all congruences, example, (2y) would match up with, if I rotate this, 2y, I think it's going to match up here with 8. So 2y equals 8, y equals 4. Now I don't see anything else here with x. It's going to match up with this side. Well, 4y. 4 times 4, this side is actually 16. So 3x minus 5 would equal 16. Oh, we're not going to get a very... Oh, yeah, we will. I thought it was going to be 11. I got to add that 5 over. 21. 7 for x. Okay? That's it. You guys should have a homework worksheet today. I'm going to give you a quick peek at that. Okay? So, if you get something like this, which you will, because this is your homework worksheet, the top row is your x, the bottom row is your y, and I would actually just go ahead and rewrite them. -2, -5, -1, 1, 1, -2. Just go ahead and rewrite them off to the side, and then do your coordinate rules. What's your coordinate rule for 180? -a, -b. So then your primes, +2, +5, +1, -1, -1, +2. Okay, those would be your new points. Got to graph both. Okay, show me all that work. You can skip 13, 14. Ooh, it's almost daylight savings time. This is good for you. Go ahead and try that one. Here you're just matching. You don't actually have to draw the angle, you just match it. Not too bad. 4 and 5 you can skip. We're not actually going to do the rotation by doing it manually. Skip those. 6 and 7, go ahead and do those. 8, go ahead and do that. Alright. Have fun, guys, and we will see you tomorrow.